In this video, we're going to focus on graphing linear inequalities. Looking at these four figures, not only do we have to graph our lines, like in regular linear equations, but we also have shading that we need to take care of, and we also need to decide if our lines are going to be dotted or solid. Now, the difference between shading above and shading below has to do with the inequality symbol in the inequality after it is solved for y. So once y is by itself, you look at the inequality. In this case, it's a less than. So anything less than, you will shade below the line that we're going to graph. The fact that it's just a less than and not a less than or equal to means that when we connect our points, we're going to use a dotted line or a dashed line. Okay? If it were to have a greater than symbol, your greater thans shade above. And again, just greater than, dotted line, greater than or equal to, solid line. So basically anything with the equal to has the solid line. If it does not have the equal to, it's a dotted line. Okay. Down here I have some steps just to keep us on track. The first step is the same as graphing linear equations. We plot the y-intercept and use the slope to find the next points. Now after we have our points plotted, then we need to worry about connecting our points. And we have to ask ourselves, should we use a dotted line or a solid line? And that would just depend on our symbol, like I said. And then we need to decide if we're going to shade above or shade below. Okay, so let's start with the first example. The first example has a y-intercept of 2. So my first point is going to be on the y-axis at 2. Our slope is 3, so that means it's 3 over 1. So from our y-intercept, we can rise 3 and run to the right 1. And since I've run out of room, I'll go in the opposite direction. I'll go down 3 and to the left 1, and I'll do it one more time. So now that I have my points plotted, am I going to connect with a solid or dotted line? And that's dependent on our symbol right here. And right here, it's a less than, no equal to. So that means we're using a dotted line. So I'm going to connect my points. Make sure you can tell that it's not a solid line. Okay. And then after we connect, we need to decide if we're going to shade above this line or below the line. And again, that's dependent on our inequality symbol, which again, it's the less than. So anything with a less than, you will shade below. So we're going to shade everything below the graph, or below the line. And what this shading is saying that, or what it's saying is that any point in this shaded region belongs to our solution set, or it's a solution to that inequality. If it's in the non-shaded region, it's not a solution. If it's in the shaded region, it is a solution. Okay? All right, so let's keep this going. Let's try example 2. Example number 2, same exact thing. We need to first plot our y-intercept. The y-intercept of this example is -1. Then we're going to use our slope which is -2 over 1, to find the next points on the line. Since it's negative, we're going to rise 2 and run to the left 1, up 2 to the left 1, and I'm also going to go in the opposite direction, down 2 to the right 1. Okay. Now that we have all of our points plotted, you need to decide if it's going to be a solid or dotted line. And since we are using a greater than or equal to symbol, that means we need to fill this in or connect our points with a solid line. The equal to's get a solid line. Okay, so after we connect our points, then we have to shade. Shade above or shade below. So since this is a greater than, we're going to shade above. So any point in the shaded region is a solution to this inequality. We could do a little test while we're here. So let's say I have the point 1, 2, 3, 1, 2, 3. So let's try 3, 3. Okay. So if I want to test to see if this point is a solution, I'm going to plug my x value in for x and the y value in for y. So we'll end up with 3 is greater than or equal to -2 times 3 minus 1. And then we evaluate to see if this is a true statement. -2 times 3 is a -6 minus 1. And we end up with 3 is greater than or equal to -7. Now, is this statement true? Yes, because 3 is larger than -7. So that confirms that this point is a solution to this equation. I'm sorry, inequality. All right, so let's try example 3. Same thing. We're going to start by plotting our y-intercept, which in this case, this case is -4. Okay. And our slope is a positive 1/2, 1 over 2. So that means from my y-intercept, I'm going to rise 1 and run to the right 2. Rise 1, run to the right 2. And I can fit one more in this direction. And I'm just going to go in the opposite direction at least one time. So down 1 to the left 2. And that should be good enough. Okay. Then from here, are we going to use a solid or a dotted line? That's dependent on our symbol right here. We have a greater than, no equal to. So since it's just greater than, we are going to connect our points with a dotted line. And then our last step for this problem is to shade our graph. So since we have a greater than inequality symbol, we are going to shade above the line. And that shading is stating that anything above this line belongs, or any point above this line belongs to the solution set. And then our last example. Same thing. We start with our y-intercept. Our y-intercept is positive 5. 1, 2, 3, 4, 5. For our first point, our starting point. And then we're going to use our slope to find the next points. It is our slope is a negative 2/3. So that means we're going to go down 2 to the right 3. Down 2 to the right 3. And just for good measure, I'm going to go in the opposite direction. I'm going to go up 2 to the left 3. Please ignore the previous example. Okay. And then now that we have our points, we're going to connect our points with a line. Is it going to be solid or dotted? Well, you look at your symbol. Since we have an equal to, a less than or equal to, we are going to connect our points with a solid line. And since it's a less than, we will shade everything below the line. Now, one last thing to point out is the difference between a dotted line and a solid line. Solid lines means that any point on the line belongs to the solution set. So any point on this solid line will make this inequality true. But that's not the case with dotted lines. Dotted lines don't have the same equality as our solid lines. So any point on a dotted line will not make the inequality true. It is not a solution. So that is the difference between a dotted line and a solid line. The point on a line, if it's solid, is a solution. If it's dotted, it is not a solution. And that is how to graph linear inequalities.